Hi, welcome to this short video on satellites data visualization. The world today is witnessing a technological revolution like never before in the history. Major part of this revolution is made possible through satellites. The mighty Himalayas you are seeing here is the product of satellites going around the planet. In this video, I have tried to briefly introduce different classes of satellites, their orbits, and mention few of their applications. The era of artificial satellites began on October 4, 1957, with the launch of Sputnik 1 by former Soviet Union. Designed by Sergei Korolyov, it was an outcome of Cold War era geopolitics. Soon, United States responded with the launch of Explorer 1 and the space race was born. Over years, several satellites were launched and many countries including India established a robust space program. Today, the changed dynamics has led to countries coming together and making collaborative efforts in space programs. One such effort is building of the International Space Station or ISS, which we see here. Flying in a low Earth orbit of about 400 kilometers, ISS acts as a microgravity and space environment research facility for astronauts. Low Earth orbit is an orbit of altitude less than 2000 kilometers. Most of the man-made objects in the outer space are in this orbit. The ISS is visible to the naked eye as a slow-moving, bright white dot because of the reflected sunlight and can be seen during dawn and dusk. At these times, the station remains sunlit, but the ground and sky are dark. With an orbital period of 92 minutes, ISS makes about 15 revolutions around the Earth every day. There are websites which allow one to spot the ISS based on observers' coordinate. The station is visible from 95% of the inhabited land on Earth. However, it is not visible from the extreme northern and southern latitudes. As we move on, what you are seeing here is a constellation of around 30 satellites called the Global Positioning System or GPS. These satellites are the ones which help us navigate by providing accurate coordinate positions through triangulation. India too has designed its own version called NAVIC, which works at the Indian subcontinent level. The satellites which you are seeing here now are in the low Earth orbits. They are generally used for Earth observation, remote sensing, communication and research purposes like Hubble Space Telescope and AstroSat. The yellow tracks seen here are of geostationary satellites. This class of satellites are at about 36,000 km from the surface of the Earth. These satellites have a revolution period same as that of the Earth's rotation period. It is for this reason they always appear to point towards the same area of the Earth. The accurate real-time visualization seen so far is made possible by what is called as two-line element or TLE format. It is a data format comprising all the orbital information for an Earth orbiting body at a given moment. This information is used for predicting the state of the body at different times. Having the TLE information of all the active satellites allows one to visualize every satellite in orbit around the Earth. TLEs are widely used for projecting the orbital tracks of space debris, close approach analysis, collision avoidance, and forensic analysis. Here we can see few Indian satellites being tracked and visualized in real time using TLE information. Satellites are important elements of weather forecast. We will see an example of how the Indian meteorological satellite INSAT 3D is positioned in orbit. It provides weather information over the Indian subcontinent. The highlighted portion is the TLE information for the INSAT 3D satellite. Using this information, the satellite and its orbit is located and mapped in space. As can be seen, it is a geostationary orbit directly above India. This photograph by Indian Meteorological Department taken from INSAT 3D corresponds to its position in the space. Likewise, other Indian satellites are shown here. This is an example of few GSAT communication satellites in orbit. These satellites provide digital communication and AV broadcast facilities, allowing DTH and other VSAT transmissions. As mentioned earlier, Indian Regional Navigation System is Indian version of GPS. It is indigenously developed. This has 8 satellites with 3 in geostationary orbit and 4 in geosynchronous orbit as seen here. Launched by Indian Space Research Organization, it has various applications. Some of them include navigation, disaster management, vehicular tracking and fleet management, mobile phone integration, mapping and geodesic data capture, visual and voice navigation for the drivers. Now shown is the real-time visualization of most of the active satellites in space. Each green dot that you see here represents an active satellite of some country in orbit around the Earth. The weather data from the satellites just before the cyclone Amphan hit India provided many actionable insights to the stakeholders in the better disaster management. The terrain information coupled with the weather data allowed the authorities to plan the location of shelter homes, evacuation of over a million people to safer places, and movement of essential items among other things. The 1999 super cyclone in Odisha claimed about 25,000 human lives. If we are able to reduce the death toll to less than 100 in a similar intense 2020 cyclone Amphan, it is a testimony to the contribution Indian satellites have made to the people of the country. At the global scale, such information helps in studies related to climate change, planetary winds, ocean currents, temperature, precipitation measurements, and air quality analysis, to name a few. As a conclusion remarks, I would say that ever since the human walked on the face of this planet, it is only now that we have been able to venture into space and look back at our home. The technological feat achieved through satellites put human at the very top of the knowledge pyramid. However, with knowledge should come the wisdom that we share this planet with others too. That we are trustees of this place with an objective to sustain it for the future generations as it was bequeathed to us. If we forget this, then nature knows to show us our real place in the universe.